Okay, with Boyle's law. So Boyle's law is a different gas law than Charles, obviously. With Boyle's law, instead of dividing things, we are now multiplying things. So what it is, it's going to be volume 1, just like we had volume 1 before. It's the volume of the starting condition. But now we're going to take it times by the pressure 1, so the pressure of the starting condition. And that's going to equal the volume 2 times by the pressure 2. Or we can write it out even simpler. V1 times P1 equals V2 times P2. That's how I'm going to be writing these out. If you notice, we're not dealing with temperature in this with Boyle's law, so that means no temperature conversion, so we don't have to worry about that first step. So when we look at our first problem here, so you have a box with a volume of 35 milliliters and a pressure is exerted on the inside of the box at 15 atmospheres. So atmospheres, the abbreviation for it is ATM. If you decrease the size of the box down to 10 milliliters, what is the new pressure pushing on the inside of the box? So we need to figure out what V1, P1, V2, and P2 are. So our starting volume is going to be the 35 milliliters, because that's what it tells us in the problem. You have a box with a starting volume of that. The pressure on the inside of it, so our pressure is measured in atmospheres, so that's P1. We decrease the size of the box down, so 10 milliliters is our V2, and P2 is what we're looking for. So now I need to plug in all of my numbers here. So I have 35 milliliters for V1. P1 is 15 atmospheres, or ATM. V2 is 10 milliliters, and then our P2 is our question mark. So just like any other problem, first thing we're going to do is write out our formula. So V1 times by P1 equals V2 times by P2. Volume 1 is 35, and I'm going to put parentheses around everything so you can clearly see the different parts of this. V1 is 35, P1 is 15, and that's got to equal V2, which is 10, and P2, which is X. So now when you look at it, we've got an algebraic expression here. You've got an algebra problem. So to get X by itself, just like before with the Charles problems, all you need to do is divide by whatever's next to X. So X equals, and I'm just going to flip it around so it's a little bit easier to read, 35 times by 15 all over 10. So when we plug that into our calculator, 35 times by 15 divided by 10, we get 52.5. So our new pressure, so P2 is 52.5. And then when you look at your unit for pressure, we're in atmospheres. So it needs to stay in atmospheres.